Welcome back, the participants, to the day 4, session 2. In this, we are going to look at the topic called Recent Trends in Security and Privacy of Sustainable Internet of Things with Blockchain by Dr. Lakshmi. Participants, this blockchain technology, by this time you have come to know what are the terminologies in this, and what is the programming concepts, and what are the various other frameworks that will help us to build the blockchain application. Mostly, this blockchain can be used as a application used in the for applying the concept of security in the transactions and all, for especially in various disciplines. So that is the reason the today's and next coming 2 days sessions are mainly focused on the applications in which the blockchain can be used. In this, the first talk is the recent trends in security and privacy of sustainable Internet of Things with blockchain. Tomorrow, we are going to see the medical based applications, and next we are going for the cyber security based applications. Then finally, we will end up the session with the the FDP with the blockchain database. So in this series of talks, the first talk is on the recent trends in security and privacy of sustainable Internet of Things with the blockchain by Dr. K. Rajalakshmi. So about the speaker, Dr. K. Rajalakshmi is a senior member of IEEE, senior member of ACM, board member of N2 Women COMSOC, and a professional member of IET SIAM. Currently, she is affiliated as an associate professor in the Department of Computer Science and Engineering, JIIT Noida. She has more than 90 research publications in various reputed peer-reviewed international journals, books, book chapters, and international conferences. She served as journal guest editor in Springer Nature and recent patents on engineering. She edited 3 books with Elsevier, Springer, and IET. Her research interests include Internet of Things, IoT analytics, cloud computing, wireless and mobile networks, e-learning approach. So, Madam will first will explain about the IoT and areas, then how the blockchain can be used in this IoT. Thank you, Madam, for accepting our invitation and for presenting this topic. Madam, you may please carry on.
Thank you, Dr. Raghu, for the introduction. So, as earlier been discussed, the topic I'm going to
Madam,
discuss
your voice
for
is somewhat
today.
low, Madam.
So the topic I'm going to discuss is about Internet of Things, and in Internet of Things, how the blockchain can be integrated so that we can enhance the Internet of Things. So is my voice clear now?
Yes, Madam. Now it is clear. Participants, the voice is clear.
Okay, thank you. So this is the outline of my talk. So I'll introduce you to IoT, and then I'll introduce you to the need for security and privacy in IoT. Then we'll see how blockchain can be used in IoT, and I'll discuss few use cases, and I'll show you a little demo of how this blockchain can be integrated for IoT applications. So IoT, Internet of Things, was first coined by Kevin Ashton. He's a British technologist, and he's the co-founder of Auto IT Laboratory at MIT. He coined the term Internet of Things. So what is Internet of Things? It is a system where the internet is used to connect various physical world things by using ubiquitous sensors. So here the connectivity may be through radio frequency identification. In those days, mainly it was focusing on radio frequency RFID sensors. So here, the main objective is that everything on the globes are connected, on the globe are connected with each other. And not only they are connected to each other, they have to sense the environment. After sensing the environment, they have to cooperatively, means collectively, they have to communicate and make up some decisions. So this is a very different from what earlier we have been talking about. ICT, that is information and communication technology, doesn't involve the environment or interacting with the environment. But when the Internet of Things came, it tries not only to connect the different equipments, but also to be very interactive with the environment through the concept of ubiquitous sensors. But IoT doesn't come as such. IoT itself has limitations. So we can put those issues of IoT into two categories, main categories. One is resource constraint. That is one of the major issue. Another one is security and privacy. So resource constraint, security and privacy, this is are the key topics where a CS candidate can work on research, can explore into it. Other than this, there are other issues like standardization, integration, and collaboration, which are other than the technical issues. But now our focus for this talk, we concentrate only on of the two major issues, which are very, very relevant to our computer science field, that is resource constraint, and another very specific to this FDP theme, which is security and privacy. So the resource constraint in terms of these IoT devices are very limited in their physical size. Other than that, they are limited by the processing unit or storage or memory or the networking capability, or these devices are mostly battery dependent devices. So the battery life or energy consumption should be monitored very high. So this resource constraint is being majority of the thing, the resource constraint based research has been going on. But the another key issue that IoT has to be taken up is about the security and the privacy. So we'll see what kind of security and privacy, that is cyber attacks and vulnerabilities, how the blockchain can be used in IoT in order to enhance this Internet of Things. So what do you mean by security in IoT? What is the expectations? So expectation is that the IoT is going to sense the environment and it's going to react to the environment. So these information, sensor informations are by inherently very, very sensitive data. So these sensitive data has to have a data integrity. And we saw the definition that these sensors are interconnected to each other. So the integrity of the data, which is the meaning that it has to be stored confidentially, and it has to be retrieved for the future use. So this kind of property is expected when we talk about security in IoT. Next is about data sharing. So again, when we recollect the definition of IoT, the devices sense the environment, it is going to react to the environment, and the sensors are going to communicate among each other. So data sharing is one of the key features where the informations are exchanged between the things, Internet of Things, and especially this data sharing is essential for a business process. For example, if it's a manufacturing organization or logistic organization or transportation or any other kind of supply chain management, all this business, they involve data sharing among different entities. We'll see this in the coming. And altogether, what is the aim of this data sharing is to provide a better life in everyday human life. So now discussing about the two major aspects of IoT, where we are really lying in the IoT. One is the resource constraint. Yes. Okay, sir. Okay, okay. Give me a few minutes. I'm just trying to do it. Is it visible now? So these are the two issues with the IoT. One is resource constraint, another one is security and privacy, which we are going to discuss in this particular talk. So how this IoT can be enhanced? One is by through the protocol levels of the IoT. I'm not going to spend much time on what is the protocol layers of IoT, but I'll give quick review of what IoT protocols mean by. And then why do we need for enabling technologies? So the IoT protocol, if you see, comparing with the TCP IP model, which has a physical layer, and then we have got a data link layer, access layer, and then we got internet, or we got network layer, and then above that is your transport layer, where you have flavors like UDP or TCP, and then in application layer you have got application protocols like HTTP, FTP, and many other protocols. Right. So in comparison to our existing TCP IP model, and to meet out our resource constraint, which is our like a limited processing unit, or limited memory, or limited battery life, and limited networking capability, we cannot go for this TCP IP model, because if you see Ethernet itself, it takes about MTU of about 1500 MTUs. So, bytes of MTUs, maximum transfer unit. So which is very expensive, because these IoT are going to sense very small data, which is within bytes, 8 bytes or maximum 24 bytes. So we can't go for this expensive TCP IP model. We need an IoT protocol adapted to this TCP IP model. So if you see from the physical layer, from the bottom-up approach, if you see the physical layer of the earlier TCP IP model supports just wireless or wired, that is IEEE 802.3, or wireless, that is 802.11. So here IoT tries to act like an umbrella, where you can have any kind of protocols. So you can have your Wi-Fi, that is wireless network. You can have your wired network, that is IEEE 802.3, also called Ethernet, or you can have your mobile network, which is called your 3G, 4G, LTE, 5G, or coming up 6G. Also, you can have your other personal area network protocols like Zigbee, Bluetooth, NFCs. They can also be supported. Only criteria is that you need energy efficient, that is low rate network access protocol. So 802.15.4 is a low rate and low data rate protocol, which is very essential for running all other protocols under the IoT environment. So at the internet layer, if you see, we have a very expensive IPv6, which is having an IP address of 128 bits in the internet IPv6, which is not essential for an IoT device. IoT device is a small device. Why do we have to address that device with the help of a 128 bit? So your 6 low pan, that is, the IPv6 has been adapted to low power wireless personal area network. That is what 6 low pan is mean by. So it is going to compress this 128 bit of IP address into mere 8 bits. 16 bits is sufficient to address one IoT device. So compressing this 128 bit into mere 16 bit is one of the very interesting part of this IoT devices. So the first interesting part is IEEE 802.15.4, which gives you at the low data rate how you can transfer the data instead of going for an 1500 MTU of Ethernet. The second very crucial thing about IoT is you can use just 16 bits to access any devices within a 6 low pan IoT local area, personal area network. And unlike our internet protocol, like distance vector or link state vector, here we are going to use a very, very dynamic routing protocol called RPL. And in transport layer, again, the IoT protocol supports UDP and TCP. Application layer plays a major role. Here we have got a very expensive HTTP where you have to send HTTP requests and then you have to get the HTTP request response. Each of this request response is going to take a IP packet of size, empty IP packet of size 1500 bytes. Instead of that, we can go for very simple and yet powerful application protocols like message queuing telemetry transport protocol and constrained application protocol. So I'm not going to talk about this constrained application protocol, but we'll discuss about MQTT, which is quite popular. It is almost used everywhere. So this is the features of IoT enhancement that has been done in terms of protocol level. But again, this is not sufficient because still we are bounded by the constraint, like simple it is a central processing unit is very limited, CPU is very limited capability, and you have limited bandwidth, you have a limited battery life. We go for enabling technologies. So enabling technologies push this IoT boundary scalable with the help of cloud computing, fog computing, and for accessing the data part, analyzing the data part, you can go for big data analytics and AI. And blockchain together with IoT plays a crucial role when we have to incorporate the security aspect into this IoT. So our talk is about IoT and the blockchain. So this slides reflect what I have been previously told about IoT protocols, like IEEE 802.15.4 is for a low rate personal area network. This is sufficient to address any kind of IoT network. So about this data link layer, that is MAC layer, sits your specific high standard layers like ZigBee, or you can have BLE, or you can have network of near frequency communications, all those things. Next, there was about the network layer, which is a 6-LoWPAN, which is also called adaptive network layer. So this sits along with your IPv6 in case of IoT. So as I told you, it's a IPv6 over low power. So our resource constraint is taken care of by this 6-LoWPAN protocol. Okay. So it basically allows our IPv6 packet to be carried efficiently within a small link layer of frames, which are defined by our IEEE 802.15.4. So together, this protocol structure of IoT gives us the more access to sense the environment and also to make decisions with respect to the sensed data. For example, suppose you want to measure the temperature of your room and you want to switch off a fan or air conditioner. So you sense the room temperature and then you take a decision and you are going to apply some actuator in response to that sensed and data. Right. So all this are working together to make that application to be efficient. Here is the pictorial representation of how an IoT network looks like. You can see these are our servers, which are following a traditional TCP/IP internet connected IPv6 protocol they are going to use. This is another traditional TCP/IP machine server, which is going to use IPv6 as its network layer. But here comes our IoT network. It consists of 6-LoWPAN network protocol, and these are small IoT sensors. And most of you, if have studied or knowledge about IoT, you must know there are two types of nodes like host nodes and then router nodes. Host nodes are having limited functionalities, whereas the router nodes have full functional devices. Right. So to address these kind of IoT devices, we just need IoT protocols. No need of this IPv6 or TCP/IP protocols. This is very expensive. This is not suitable for our resource constrained devices. So you can see that, as I told you, 16-bit is sufficient to address each of these IoT devices with respect to this 128. This is a 128-bit representation of IPv6. This is, if you expand it, you will get 128 bits. So this is very, very expensive way of approaching the IoT, right? This is the background of IoT. Moving towards the upper layer, that is application layer. MQTT is a very nice replacement of HTTPS, which is very, very expensive. You have to first send a HTTP request, then you have to send HTTP response. Altogether, you have to transport layer, you have to perform three-way handshaking. These are all very, very expensive bandwidth consuming approach. Whereas MQTT application layer protocol is a very lightweight and efficient protocol for IoT. And here you can, no need of the client and server to be, available throughout. You can send the MQTT in case of small message headers, are unlike you have a lengthy message headers in case of TCP/IP protocol. Here we have got small message headers. Also, these MQTT can be applied on smaller microcontrollers, that is resource constrained IoT devices. And MQTT supports bidirectional communication. This is a wonderful feature of MQTT. This is scalable because we can connect it to the cloud. I'll show you very shortly. You can scale to millions of things. Things means millions of IoT devices. And here also you can perform a reliable message delivery. Why do we go for internet TCP? Because it gives you a reliable communication connectivity, right? Similarly, MQTT also gives you the flavor of reliability, very similar to our TCP/IP. So we'll get a little detail into this. What is this MQTT application layer looks like? Basically, it consists of two major components. One is called MQTT client. You can see in the figure, there are 3 MQTT clients and there is one broker. Okay, and they all are connected together through internet. So internet is the medium of communication between client, broker, and different clients apart. And then this client is further divided into 2 types. One is publisher, another one is subscriber. So on the left hand side, you can see that there is a publisher. On the right hand side, you can see there is 2 subscribers. So who are publishers? Publishers could be your assets. Assets means like sensors, or it could be some documents, ledgers, or it could be some contracts. Okay, these are all assets. And who are the subscribers? It could be a client, it could be a manufacturer, it could be a supplier, or it could be a manager, or it could be a controlling unit, management system. These are all subscribers. So what a broker does is that broker is basically a cloud environment. He sits in the cloud. So this reduces the burden on the publisher and the subscriber. This is the wonderful feature of IoT, how it can be scalable. So when a publisher senses the environment, for example, here we are having a temperature sensor as our MQTT publisher. He publishes the data, he sends the data and he publishes in the form of topic. So topic is the measuring unit, or the unit which helps to transfer the data from one end. In the form of a topic, we transfer the data. So the measured temperature is 32 degrees centigrade. And once the publisher had published the data to the broker, he may be available to the broker, or he may disconnect himself from the broker. So these standards are set by quality of services. MQTT gives you 3 quality of services, 0, 1, 2, and 2, 0, 1, and 2. So depending on the quality of services, you can make the connection between the publisher and the broker. Coming to the subscriber part, the subscriber can connect to the broker and he can choose whatever the topic he is interested. For example, here is this particular subscriber is interested to fetch the temperature which was given by the publisher, this publisher. So he subscribed to this temperature. Again, he can set his own quality of service. We call it as QoS. Basically, here also we have got 3 levels of QoS. That is 0 to 0, 1, and 2. Indicates low quality of service, medium, moderate, and then reliable service. 2 is the highest standard of quality of service. And then publish data, and he can retrieve the data from the broker. So you can see that there is no need of publisher and subscriber to be present all the time. So whenever the subscriber is in need of data, he can fetch it from the broker. Okay, similarly, it is another example is given here with the MQTT subscriber, where he also is in need of a temperature as a topic, and he wants to get the data measured by this publisher. Just give me a second. So coming back to our security, I think the slides got mismatched. So coming to the security in IoT, we have discussed what is data integrity, data sharing. Another aspects of security in IoT is through authentication access controls. These IoT devices are going to sense data from the environment. So it is essential that they are not misused by unauthorized access to the resources or sensitive information in the IoT system. Moreover, we need to have a scalability of the system. So if you see our IoT protocol, moreover, they are giving you all these things. But still, the security part is untouched, right, in case of IoT. And then another security issue with IoT is about privacy, where you need to have privacy, or we need to maintain an authenticated or unaltered pure data which was actually sensed by the IoT system. It should not be altered or knowingly or unknowingly. So it involves a variety of small devices and sensors. That makes it more complex to bring security in the IoT. And another difficulty with IoT is that a comprehensive decision has to be taken together as per the requirement of the system. So in case, even if a small amount of privacy is violated, then there is a huge loss in the function of the entire IoT system. So coming back to the security aspect of what happens with the IoT, instead of theory, I'll just give you some live view of what this IoT, where is this? I'll share my entire screen. Is my screen visible? Okay. You can see that is this NetScout is visible, this website is visible. So you can see this is the live update of how many threats, attacks have been happening throughout the world. This is a live telecast, right? July 28th, and this is the universal time pay. This is this many. At present, we have got 172 this distributed denial of service attacks are happening across the world. So you can see this is per second. per second, microsecond, we are having this much amount of DDoS attack. So it is expected that the IoT devices are going to grow exponentially, grow in millions and millions. By 2025 they are expected to reach at least 5 billion of IoT devices are to be existing on the world. Right, there is going to be more number of IoT devices. So these IoT devices are very, very vulnerable to these kind of security breaches. So this is just one attack I'm showing, that is a DOS attack. But you can see there are several other vulnerabilities that exist. As I told you, one major problem is altering the data or load altering. In case of microgrid, load altering is a very, very, very crucial security threat. Likewise, every application has its own threats, very specific to the applications, right? So this is the live example of what is the current status of what's going across the country, across the world. So here is another visual representation of how many attacks. These are all live, right? These are live data. And you can see that the topmost countries that are suffering from worst botnet is China and India, United States, Indonesia. That's why I kept this particular. And where these botnets are coming from, they are coming from mostly from Amazon. In India, it's from Airtel. They have sequenced it according to the number of attacks, threats that are coming because of botnet threats across the world. So this is another important visualization of how worst the threat is in the world, across the world. So give me a second. I'll move back to my presentation. So many speakers has discussed about blockchain. So blockchain is one of the best available solution for our this security and privacy in terms of decentralized approach. So this slide has been discussed by several speakers earlier also. So what happens in the blockchain is, like, whenever any node wants to transmit the data in the form of transaction, the data will be sent to the peer-to-peer network. Then they perform validation based on the consensus mechanism. Then a block is created and a validation of the block is performed by the miners. Then you get added to the blockchain, right? And this is the transaction identifier, transaction format. So I'm not going into these details. Okay, this is not my area of cup of interest. But however, I'll just quickly go through it. What are the kind of algorithms that are available with the blockchain? We have proof of work. For example, we have Bitcoin and Ethereum. Proof of stake, we have Next. And proof of elapsed time, we have Sawtooth. BFT, Byzantine fault tolerant, we have Iroha, Apache, Kafka, and Zookeeper. They are based on Hyperledger Fabric. So these algorithms are different in terms of their quality of services. like IoT has different quality of services, these blockchain algorithms also have their different type of quality of services. So those who are very new to blockchain like me, you can go to this website. This is andresbrownworth.com blockchain. He is a MIT professor and he has given a very nice visual experience of how the basic blockchain functions. Those of you are already know, you can clear your concept based on this. So here he has built around 6 types of stages of the blockchain. First, he has defined how the hash looks like. So the hash is based on SHA-256 hash. You can generate your hash, and this is the data. For example, my IoT device is going to give me some temperature. You can see that the hash is getting changed instantaneously depending on each character you're trying to enter. Next is the next tab gives you the block, how the block is created from the hash that is being generated. So you can see, like, again, if you type any character in this, the hash keeps changing. And then the next tab gives you the blockchain, how the blockchain looks like. So it is the collection of blocks. So here you can see basically 5 blocks have been created, and how each block is generated is chained from one block to the another block. You can see that the block identifier nonce, and then data, what was the previous hash and what is the new hash that is created out of this newly added block. So this demo gives you about 5 blocks that are created. The next level of blockchain is distributed blockchain. So we all were wondering how this peer-to-peer network works. So this distributed one is going to give you a peer network visualization. So here there are 3 types of peers he has given. So this is peer 1, peer A, this is peer B, and this is peer C. Each one of them are communicating each other in a peer-to-peer manner. So you can see that peer A has 5 blocks in one single blockchain, and you can see, you can mine and see also how the mining is happening, and then whether the block is valid. It will be get validated every time, right? Whether it turns its color. So the block is successfully added to the blockchain. Like that, you can work out and see. Also, he has given token-based blockchain as well as coin-based blockchain. Those of you interested can go and recollect your foundations on blockchain. So definitely blockchain is a promising solution for IoT also. So these are some of the areas that the blockchain based IoT applications are, like democracy, government, law enforcement, telecommunication, defense and public safety, farming, financial transactions, collaborative and crowd sensing, smart cities, healthcare, personal sensing, smart living, logistics. Industrial 4.0 has a huge influence of the blockchain technology. And then we have got transportation, smart object, fleet management, logistic management. These are some of the blockchain applications of blockchain in IoT. Now we'll go into the core of, we saw what is blockchain, we have seen what is IoT, how they both are connected to each other. We'll see a small demo of how these things are going to work together. So viewing IoT as entities of IoT, you can have it as assets. Assets are nothing but the sensors or actuators or any kind of inputs that are given to the IoT systems. These are called assets. So for example, here you can see that it is a temperature devices. It could be a GPS location based devices, or it could be a vehicle like truck or ship, or it could be a contract between documents, or it could be any kind of shipment, parcel or courier or something. These are all assets. Okay. Who are all participants? Participants are the human entities mostly. There is an involvement of human directly in this participants. They are mostly importers, manufacturers, shippers, or managers, or any kind of administrator who is controlling any kind of system. They are all participants, right? And what is transaction? Transaction could be a shipment allotment, it could be a submission of IoT reading, or it could be inducting of a package, whether the package has been received correctly or not. So these are the three entities that play a role in case of blockchain IoT, a blockchain in IoT. Okay, so now earlier I was talking about IoT devices. Now I put the perspective in another dimension with respect to the blockchain. So we have seen two different things, like what is blockchain we have seen, and we have seen what is IoT. Now integrating together this thing needs another perspective of view, where we have got three different entities like assert, participants, and transactions, right? So mainly we may want to store this transaction for future references, future uses, and for data analysis or data processing purpose and decision making purposes. So it depends on what level of blockchain, what sophisticated blockchain you are trying to use. Okay. So coming back to our IoT, this is what we have seen in IoT. Okay, so I'm trying to give you a big picture of integrating IoT. This is IoT. We have seen IoT system, how the IoT system looks like. For example, I earlier used the same term like MQTT client and MQTT client and then MQTT broker. We have two types of clients like publisher and subscriber. And in this example, I have got two different clients itself, publisher itself. One is a truck carrying a package, another one is a ship carrying cargo, a larger amount of. So both of these temperatures, a sensor is our asset, and senses the temperature within the container, and it is going to publish to the MQTT broker. So they all are interconnected through internet, and MQTT broker is a cloud-based broker. And subscriber can connect to the MQTT broker and can fetch the topic. So you can see that the topic of this truck is temperature 1, topic of this ship is temperature 2. So this subscriber is subscribing to the temperature of the ship, cargo ship, while this subscriber is trying to receive the topic of temperature 1 of the truck. So this is using temperature 1 as the topic. So this entire thing is vulnerable to the DOS attack. We have seen how the DDoS attack is happening across the world. Visually, we have seen per second at least 200 per microseconds. It's all counted in microseconds. We come across 200 to even 500 DOS attacks across the world is happening in a bulk. Okay, it's essential that we have to protect the data integrity and data privacy, access control, authentication, and everything has to be monitored. And the best solution for us is the blockchain, using the blockchain. So I'm not going into the details of blockchain, how the blockchain is going to function, but I'm going to show you how I can use the blockchain for an IoT application. Okay. So as previous talk speakers have already told you how to select a particular blockchain for any particular IoT applications, there are certain conditions you have to meet, And most of the IoT application meet these criteria, like is there any involvement, is there a necessity for a blockchain for this particular type of IoT application? Are there copies of ledgers involved? Are there any redundant copies or multiple computers, or a distributed network is involved? Are there trustworthy entities involved in that? Multiple parties are involved in that. Are there third party involved in that? Or we are going to have a restricted private network, or it's going to be a public network? Accordingly, we can choose different types of blockchain strategies as a solution. Right, I'm not going into the details of these things. My interest is of about IoT systems. This is different use cases, like a healthcare provider wants to add a new medical record for a patient. Okay, so he may use a blockchain to store the data and retrieve the data, and these blocks can be verified, and they can be validated by using blockchain algorithms. And another use case could be for agriculture purpose, where the farmer can validate his products, whether he is having a very good product, what is the grade of the product, what is the grade of the grains that he is able to produce. Or he may come up with a contract between the farmer and any kind of government organizations, so that he can get a profit for the production he has made out of his agricultural land. So this can also be verified, can be implemented by using the blockchain approach. So this scenario, these are all taken from the research papers. Another use case is the cargo, as I told you, like manufacturers, or it could be a logistic partner, or storing warehouse, or it could be a retailer, or it could be a middle management, customer relationship management. So how they can be, different blockchains can be integrated together is also, in case of retail industry, this is the third use case. We are one of third example of how the IoT and blockchain can be integrated. It's not like that. The blockchain, using the blockchain in IoT has its own challenges. One side, I told you, it is a resource constrained device, and it is a low latency. It has a very low network capability, and it is largely scalable. It has a large number of IoT devices involved, and it has a limited bandwidth and energy resources. On the other hand, if you see, the blockchain is a resource consuming, because you have to store every transactions, and block mining is specifically, it is a very, very time consuming, and it scales poorly in case of network sizes. We can't have a blockchain of millions and millions of devices. And blockchain involves, since it involves a computation time, lot of transactions, it is bandwidth inefficient. So those who want to pick up research in this area, they can look into what possible solutions could be there to bridge this differences in the blockchain and the IoT. Okay, so with this, my presentation is over. I'll try to show you what we have seen. The same thing I'll show you using a not a simulation, in a real environment, how this blockchain and IoT go hand to hand. Okay, so those who are interested can discuss with me later on. But right now, I'm not sharing how to installing the software and all. I'm not going to discuss. Okay. Is my screen visible? Okay. So this is an environment called Node-RED. So let me explain what is Node-RED. Node-RED is a visual programming environment. So visual programming environment means those who are very lazy to do programming, like me, you can choose this Node-RED option. But then it's a complete full stack. It has a very wonderful feature where you can emulate the environment. You can connect your IoT devices and see the real working of the IoT devices, how the devices can sense the environment, as well as how it can control the environment. That is possible in the Node-RED. So it is basically a visual programming. And how it is built up? It is built up on Node.js. So we have been talking about Node.js throughout this FDP. The very base this Node-RED also uses. It's mainly based on the JavaScript. Very minimal JavaScript coding is required. Unlike if you see your Solidity or your any Visual Studio based coding, Node.js coding, you write a very lengthy coding, right? A simple even block creation needs hundreds and two hundreds of lines. So those who are lazy to write such a lengthy code, you can prefer to go for Node-RED. Node-RED has all the functional units in terms of nodes. So here the entity is called nodes. Instead of writing function, you can call it as nodes over here. So all the nodes provides you pre-built functions. You can say pre-built functionalities. Okay, this is the structure of this is the GUI or ID of the Node-RED. So Node-RED, simply you need the Node.js, what you have been seeing throughout this FDP. Upon that, you have to install the Node-RED from the Node.js command prompt. So for that, you can go and refer the Node-RED. I'll share another PPT. So I'll be switching now and then. Is my screen visible? So here is the Node.js. You can install it from nodejs.org. You can install it for Windows. You can install, and for Mac also it is available. Next is from the Node.js command prompt, you have to install the Node-RED. So the command for the Node-RED installation is, I have highlighted here. If you can see this is npm install -g -- unsafe space node-red. So it's a very simple installation. There is no hodgepodge. You can straight away install this npm. Node-RED is ready. So next you have to open any command prompt. Usually if you are using your own standalone Node.js, you can straight away start using from C drive. So you can first you have to type check once your Node.js is installed. You can type node and you can check the version. It's preferable that you install the latest version, at least 16 and above is preferable. And then you have to check for the Node-RED, whether Node-RED installed or not. I have shared the command for installing the npm of Node-RED. So this is the command. Once it's installed, your command prompt is ready for Node-RED. So you just have to type Node-RED on the command prompt, and this is the Node-RED server that is running on the Node.js platform. Okay, so this is the basic. Now I'll move to the actual implementation. I'll move. from the command prompt, when I type node-red, see my server started. Okay, so once the server is started, it will assign you, because I have already a server running, it is giving error. So you have to type localhost, and the port number that your node-red will be running is 1880. So this is the node-red where it runs on your local machine. Localhost 1880 is the place where your node-red will start working. Is my screen visible? Sir, is it visible or not? Now? Yeah, so this is the node-red that is running on my local machine. That is HTTP local 1880 is the port number where my node-red is working. This is how the node-red looks like. So this is a visual programming environment, and you can see that it has 3 columns, basically node-red. There is a left column, there is a central flow area, and the third one is deployment area. So the left has different nodes. As I told you, these are all functions, different functions. You can simply drag and drop it. And this is the flow area where you can create flows. Flows are like you're writing functions and calling functions each other. Similarly, here we drag and drop each functions and we connect through the link, or we call it as flow. So I'll enable this flow. So what we have seen earlier was that there was a MQTT broker. So the major MQTT broker that I have used is called ADIS broker. So if you recollect our picture, there was a MQTT broker, there was a subscriber and client as publisher and the subscriber. So here also I have got a MQTT publisher and one subscriber I have put up for easy understanding purposes. So here you can see that this is a publisher where he, in our example, we were trying to use a temperature sensor as one of the asset. Here I'm going to use a home automation environment where I have control over the switch so that the bulb can be switched on or off. Okay, so here one of the function that I have dragged, you can go and see here, or you can simply type switch. You can see these are different types of gadgets or widgets available within the node-red. So they performed perfectly like our hardware only. So if anybody is interested to work on real IoT devices, only thing is that you have to add that particular RPM. Suppose you are using, instead of switch, you are using a microcontroller board and you connect a push-up button with one pin of the Raspberry Pi, and you want to control the pin, you can perfectly do it. Instead of here switch, you have to just use a Raspberry Pi general IO pin. You have to just add that library over here and you can drag and drop it. It works perfectly. In fact, Raspberry Pi itself comes up with this node-red, as well as Arduino also supports this node-red. Both of the devices supports this node-red platform. So now this is the MQTT publisher is a simple switch which controls the glowing of the bulb in a smart home. And here is the MQTT broker. So this MQTT broker, that is ADIS MQTT broker, is one of the MQTT broker that comes default with our node-red. Right. So I'm going to connect the switch to the MQTT broker. And on the subscriber side, if you can see, there is one subscriber. In our example, I have shown one mobile phone and computer. Here it's a bulb. I have taken bulb as one of the subscriber. So we are going to see whether the bulb is going to glow or not. So you can see that both of this MQTT client and MQTT subscriber, they are connected through the broker through this function MQTT. You can go to this nodes and you can see that MQTT in and MQTT out. So I'll use this MQTT out function of node over here and MQTT in node over here. And they both are the parts of the MQTT broker called headers. So when you double click this particular node, you can set the priority of this node. So I told you, those who are very lazy to do programming but love to click the mouse, they can prefer this way of, instead of writing lengthy line of course, you can just go and double click on this nodes and you can set. I have set this already, it has been set, and this MQTT broker is working on the port number 1833. This is by default, it has selected, but as a user, you can choose any port. So those of you are really interested to work on Node-RED and blockchain, we can discuss offline. Because of time constraint, I'm quickly go through it to give you the flavor of how this IoT can be worked with blockchain, right? And realizing it. So this blue dot over it tells that my broker and all the nodes are working perfectly. So switch I have explained. Bulb is nothing but a text box I have used to display that whether the status of the bulb, whether the bulb is glowing or the bulb is off whenever I operate with this switch. A message payload is like output. We have seen this in Node.js also. Message payload is interacts with the debug output. You can see through the message payload. So let me to execute this, we call it as a flow. To execute this particular flow, we have to deploy it. So I'll press the deploy button over here. So it is successfully deployed. You can see that some activity is going on. The bulb has been, I'll delete first. Let me delete everything. So you can see that this is this little ant over here. This is called debug window. You can go to the debug window. Those of you interested can explore each of these tabs. Now I'm concentrating only through the debug window. So this environment gives you like a web-enabled interface. So I'll go to the web-enabled interface and show you how exactly the node is going to look like. So this is the smart home environment. I have one switch. For example, I have taken. I have got one bulb, and by controlling the switch, I should be able to switch on and off the bulb, okay, light bulb. So I'll use this for simulation purpose. I'm using this slider widget. So switch widget I'm using. So when I move to the left side, it goes gray and the bulb goes off. So similarly, when I control the switch to the right hand side, then the bulb glows. Okay, the bulb is on. So in reality, in real scenario, this perfectly works. Instead of switch, I'm going to use a Raspberry Pi, an IoT device, and I'm going to use any on of a switch, dual this by a Boolean switch, and the bulb is going to be any motor. It could be any any kind of actuators. Another example could be like in case of healthcare, IoT healthcare system. This switch could be a health monitoring system. For example, pacemaker of a patient. It could be a wireless personal area network of a pacemaker, whether the heartbeat is correct or not. That could be the function of the switch. And bulb status is that whether the reading is perfectly coming or not. So it is up to the developer ka creativity, how you want to have this IoT system to be. In this example, I have taken a very simple MQTT client and a very simple MQTT subscriber. So you have to understand that main thing is that this switch is far away and this bulb is far away, but they both are connected through the MQTT broker by means of internet connectivity, right? So this is how the MQTT works. Now next we will move to how our blockchain can be integrated to this IoT environment. So here, so again, this scenario is very similar to you. So there is an inject node. Instead of switch, I have used an inject node where I can inject the data into it for understanding purpose. I'll clear all this data. So here you can see that that is a MQTT, same MQTT broker, and there are two one publisher and one subscriber MQTT. Now, where can I use this blockchain? So you can see that I have shown you a visualization that this kind of system is quite vulnerable to this specific attack of botnet, or it could be a DDoS attack. So one such kind of blockchain solution is Neblio. Neblio, you can go and explore it. This is a coin-based blockchain, and it is freely available. It's an open API. So I'm not going into how to install, just it's all very simple command. You have to just put, this is the API. So you go to Swagger Neblio. This is the blockchain, open blockchain, and you can go and access the REST API suite by using this IP address, right? And this is in the form of JSON. You can fill that, get the API, REST API from this particular path URL. So this Neblio, it's Neblio blockchain. If you want to go and study the detail, Neblio is a distributed high-performance blockchain platform built for enterprise and industrial 4.0 application and services. It's open for, especially for community purpose, they have opened it. So here, Neblio I have used, instead of straight away going and publishing my data. Sometimes these are very sensitive data. I need to maintain the privacy and the integrity. In such case, I go for a blockchain. So Neblio is, I don't have to do programming, but these are all based on Node.js, right? So I'll just click the node and I initialize each parameters. So I'll put the URL, and then you have to select this. There will be like a check. You have to check whether it is able to receive the data from the Neblio blockchain. So click OK, and you have to choose this standard as the error handling mechanism. And the API that we are going to fetch is a return address object. What is the object address? Basically, what is the blockchain object that we are created, address of that blockchain we are going to have. And then request content type is in the form of JSON. And then we are going to give the output to the message payload. So this is done. This is what you do when you try to program the Node.js or on Solidity. You do the same thing, right? Instead of that, I just drag the node and then I initialize some of the parameters. That's it. So now I'm going to, now my data is secured, right? I have a secured data which has been in the form of transaction, and blocks are created. They are added by the mining purpose, and the blockchain is created. And then it's communicated perfectly between this MQTT broker and the MQTT clients. That is one publisher and the one subscriber. So he is the subscriber. You can see this is a MQTT subscriber. So this is the MQTT broker local address, and this is the topic. So in our example, we have seen temperature as the topic. Here we have used home as the topic. And I told you MQTT gives you 3 types of quality of services. And retain is one of the feature where it retains its value even if a disconnection happens. Similarly, these are the simple example of how blockchain can be integrated with our IoT systems. So I'll deploy it. It is deployed successfully, and I'll clear all the messages. When I inject data, you can see here that it is able to retrieve a chain has been created, a block has been created, and the details of all the parameters like header, what kind of text, what kind of data, what is the body. This is a HTTP response, right? And these are the details about the blockchain that has been created, like what is the balance statistics, totally how many received, how many sent, how many confirmed, how many text appearance, transactions, all those things. So I'm not going into the details of this. So this information can be transferred to the IoT actuators, like this could be a bulb, and which again you have to parse it. This is unparsed data. And these are all in the form of JSON. You can see the entire object in the form of JSON. So you can parse each of this field, and you can activate according to your need. Okay, I'm skipping that part of parsing this blockchain details, and you can perform some operation. Because of I don't want into too much complication, my focus was on IoT. Rest of anybody's interested in how to use the IoT and blockchain together on the Noida environment, we can discuss offline. So that's it from my side. Any questions, or if it is running out of time, we may discuss offline also.
Madam, you are on mute, madam.
Whatever you're typing in my node red, I have inject node gives me some random number. It could be a string hello world, or it could be a sensor data, right? That goes into the data part of your block. That will be hashed and then become the part of your blockchain, particular block, and then blockchain is created.
That means for that any module is directly available in Node.
Directly, everything is direct. That's what I tell you. Node-RED may the function is performed by the Node-RED API. For example, Nebulio API does that function by itself. Okay. The blockchain is created by itself. It's an open API. You don't have to put any effort.
Okay. Okay, participants, if you have any doubt, you may please ask.
Nebulio is one particular open blockchain API. There are several. There are almost 200 blockchain APIs or open APIs are available. You can explore all.
Okay, madam. So I think there is no question from the participants. Okay, madam. On behalf of participants and the organizing, I thank you once again for spending your time and presenting the topic of security and privacy and IoT and how we can overcome using the blockchain.
Raghu sir, I think someone is asking for, can we have your mail ID for further discussion? My first slide, I'll type, has the details. Anyway, I'll type here also. I'll type it on the chat box, okay? Okay, thank you all for listening to me patiently. I was a little hurry up because my interest is IoT, but then I have to give the listeners also some kind of flavor to blockchain. I tried my best to present. Otherwise, thank you everybody for being so patiently listening to me and raising questions also.
Thank you,
Thank you.
madam. Thank you a lot. Thanks a lot.
Thank you.